Okay, I'm just going to go through the beginning of the blend space and point out a couple things. I think what we're doing today is pretty conceptual, but let's take a look at solubility. So we're talking about solutions, and solutions require a couple of things. One, that we have a homogeneous mixture of at least two substances. Homogeneous, again, means that it's evenly mixed. And the proportions of the substance are not fixed, which means we can have more or less proportions of solvent to solute. You can have salt water with a lot of salt or salt water with just a little bit of salt. It's still a solution. And it's also only going to be in one phase, one state of matter. The two components that make up our solution is our solvent, which is the substance that does the dissolving, and it's usually present in the largest amount. And the solute is the substance that is dissolved, that's broken up in the solvent. Solute can be solid, liquid, or gas. But when we have our solute dissolved in our solvent, we call the whole thing a solution. Solution is a solvent that dissolves a solute. We can have all kinds of different types of solutions. There can be gas, liquid, or even solid solutions. Air is an example of a solution where oxygen dissolves nitrogen gas. So that's a gas-gas solution. Soda water involves a gas dissolved in a liquid. Carbon dioxide gas is dissolved in water in a Coca-Cola or a Pepsi or a Dr. Pepper. Let's see. Liquid and liquid vinegar is acetic acid dissolved in water. Seawater is sodium chloride, which is salt dissolved in water. It's a solid in a liquid. Iodine tincture is iodine, solid iodine dissolved in alcohol. We can even have solid solutions. Dental amalgam involves mercury dissolved in silver. Steel involves carbon, solid carbon dissolved in iron. And all of these are solutions. Let me quickly just pull up the chat to make sure I'm not missing any chat. But let's keep going. Oh, there was a question in chat about the personal project presentations. No, you're not giving an hour-long presentation, but you'll be in a session that lasts an hour. So you'll have to attend an hour-long session. Your presentation will probably be about 5 minutes. And there will be maybe 10 or so other students all giving 3 to 5 minute presentations on their personal project. So your presentation is going to be quite short. You'll have to be quite quick. But you'll have to stay for the entire hour meeting because you're going to be, well, you're going to be the audience for your classmates. Okay, so next thing we want to talk about is solubility, which tells us of the maximum amount of solute that will dissolve in a given amount of solvent at a specific temperature and pressure. So solubility changes at different temperatures and pressures, which is why we have solubility curves. Usually we express solubility in grams of solute per 100 grams of solvent. But you have to be careful because sometimes solubility is expressed in grams of solute per grams of solution, which would be the solute plus the solvent. And it changes the math when we're dealing with the different units. We're not going to be doing much math today, but we will as we will do more in the next coming days. But just be careful about your units. Careful about your units. If you have solid solutes, in order to dissolve better, you want to stir your substance or grind your solute into smaller particles. If you have finer salt crystals, they'll dissolve faster. Also, if you heat up your substance, it will dissolve faster. If you have a gaseous solute, you want to increase the pressure to push more of that gas into your other gas or liquid or solid. You want to decrease the temperature of your gas so it's not moving as fast, so it can be captured more easily. Solubility curves are usually given with the x-axis as temperature and the y-axis as solute in grams per 100 grams of solvent. And the curve here, the actual line, tells us the saturation point of our solution at a given temperature. So at lower temperatures, if this is salt water, for example, at lower temperatures, we can hold less salt. At higher temperatures, we could hold more salt in our water. Everything below the curve can also exist. You can always have less salt than the maximum. We just call it an unsaturated solution. Everything above the curve is a supersaturated solution. You saw in the video what happens with supersaturated solution. Supersaturated solutions can exist, but they're unstable because we have more dissolved than is normally possible. And as we saw in the video, if we have a supersaturated solution, we can get crystals that form if we in our supersaturated solution, if anything disturbs it. So unsaturated means that we can dissolve more solute in our solvent. A saturated solution is when no more solute dissolves. If you're ever making salt water, you fill it up with salt, you warm it up, and you stir it. At a certain point, no matter how much you stir, there's gonna be some solid salt at the bottom. That's when you're saturated. If you're super saturated, you won't see that very often, but if you add any additional salt, you'll get crystals that form. Here's an example of a solubility curve and a quick question. So if a solution had 100 kilograms of solute dissolved in 80 degrees Celsius solvent, is it saturated? 100 kilograms of solute per 100 kilograms of solvent. So let's just look at the units on our graph. This is kilograms per 100 grams water. This is temperature. If we're at 80 degrees Celsius and we have 100 kilograms per 100 kilograms, we just got to find that on the graph. 80 degrees Celsius, 100 kilograms per 100 kilograms. It's below the line, so it is not saturated, which means we can add an additional, it looks like it's more than 25. It looks like we can add about 30 additional kilograms of water, or sorry, 30 kilograms of solute per 100 kilograms of water. So in a 100 kilogram vat of water, we could add another 30 kilograms of that solute. Any questions about reading graph? Okay, so this is going to be our group practice. It's a bunch of different questions about the graphs on the next slide. Right here. So here we have the solubility curves for several different substances. They're all labeled correctly. Let's do numbers 1 and 2 together. Which salt is least soluble at 10 degrees Celsius? Which salt is least soluble at 10 degrees Celsius? So this is solubility, grams of salt per 100 grams of water. Which is least soluble at 10 degrees Celsius? Well, at 10 degrees Celsius, potassium chlorate is the lowest value of solubility. So potassium chlorate is our least soluble at 10 degrees Celsius. Number 2, how many grams of potassium chloride can be dissolved in 100 grams of water at 60 degrees? So grams of KCl in 100 grams of water at 60 degrees. Grams of KCl, so that's this blue line, in 100 grams of water, which is our unit here, at 60 degrees. So we just need to go to 60 degrees, find our KCl. It looks like it's right halfway between 40 and 50, so that's going to be 45 grams of KCl. Wait, did that say 50 degrees? No, 60 degrees. Yeah, 45 grams at 60 degrees. I'm going to do one more, just to remind us that we need to be really careful about our units. How many grams of sodium chloride can be dissolved in 50 grams of water at 90 degrees Celsius? Sodium chloride in 50 grams of water at 90 degrees Celsius. So here, where's sodium chloride? That's this light blue line. At 90 degrees Celsius, our solubility is about 40 grams of salt per 100 grams of water. So if you put 40 grams, you're going to be wrong. Because it's asking how many grams of salt can be dissolved in 50 grams of water. So we have to divide our answer by 2. Because the units in our graph are 100 grams. So if we want 50 grams, then we have to divide our answer by 2. So our answer would be 20 grams of sodium chloride. Okay. Let's send you to your breakout rooms to work on the rest of these, and I'll give you about 20 minutes to do that. Well, which salt is least soluble at 10 degrees Celsius? So we're going to go to 10 degrees Celsius, and whichever one has the lowest solubility value is our least soluble one. That's this brown one, the brown line, so it's KClO3. KClO3. Number 2, how many grams of KCl can be dissolved in 100 grams of water at 60 degrees? So we find KCl, this dark blue solubility curve. How many grams can be dissolved at 60 degrees? So we go to 60 degrees and we scroll up, find what KCl is at 60 degrees. And it looks like it's exactly halfway between 50 and 40 per 100 grams. So that's 45 grams KCl can be dissolved in 100 grams at that temperature. Number 3, how many grams of sodium chloride can be dissolved in 50 grams of water at 90 degrees? At 90 degrees Celsius. So this is sodium chloride, 90 degrees. So 90 degrees, and I'm going to go up until I find sodium chloride. So looks like it's right here. Sodium chloride is this light blue line. And so that value is about 40 grams. 40 grams of salt per 100 grams water. So how many grams would be in 50 grams? Well, I could do the math. 40 grams per 100. Oh, per 100 grams equals X over 50 grams. And solve that for X. Just set up a ratio. And I get that, well, since the bottom is half, the top is also going to be half. It's going to be 20 grams. 20 grams. It's 40 grams of salt per 100 grams of water. So if we only have 50 grams of water, we only get 20 grams of salt. Is the screen share still working for everybody? Okay. Number 4, classify the type of solution at 70 degrees, 20 grams of KClO3 is dissolved in 100 grams of water. So at 70 degrees, I'm going to find 70 degrees. And 20 grams is dissolved in 100 grams of water. So 20 grams of salt per 100 grams. That's going to be this point right here. I'll label it 4. Okay, so at this point, are we under, above, or on the line for KClO3? We're under it, so that means it is under. saturated. Number 5, classify the type of solution. At 50 degrees, 50 grams of KCl is dissolved in 100 grams of water. So 50 degrees is our temperature value, and then 50 grams per 100 gram is our solubility. This is number 5. And it is above the line, which means we are supersaturated. Supersaturated. See how all these problems basically just involve reading our graph. Number 6. Looks like the screen share is loading very slowly. It's just finally drawing our coordinate for that. Number 6. A saturated solution of KClO3 is formed from 100 grams of water. Well, that's good because we have 100 grams over here. If the saturated solution is cooled from 70 degrees to 30 degrees, how many grams of precipitate are formed? Precipitate is going to be the leftover solute that is not dissolved. It comes out of our solution. So it's KClO3, and it started at 70 degrees, so I'm gonna draw a dot at the starting point. And then it's cooled to 30 degrees, so it goes down to here. How much precipitate comes out? Gosh, it is loading very slowly. Well, initially, if it was saturated, there would have been 30 grams of salt. And then at the end, at 30 degrees, there's only 10 grams of salt. So if we just look at the change in solubility, we can see how much drops out. 30 minus 10 is minus 20 grams per 100 grams. So 20 grams is going to fall out. Number 7, a chemist, oh, and I should label this number 6. Number 7, a chemist adds 84 grams of KNO3 into a test tube which contains 100 grams of water. Temperature of the water is 40 degrees Celsius. How much of the solute will be left undissolved at the bottom of the test tube? So 84 grams, that's going to be up here. 84 per 100 grams, so that is going to be up here, and the temperature is 40 degrees. So I'm going to find my coordinate, 40 degrees, 84, go a little lower, 84 grams per 100 grams of KNO3. But because I added, but because this value is greater than the actual value, the solubility at this temperature, and all this extra salt that I added is just not going to dissolve. And the difference, or the amount that doesn't dissolve, is this difference. It's negative 20 grams, is 84 to 64. So it's just going to be 20 grams is left. Last question. At what temperature can 80 grams of sodium nitrate be dissolved in 100 grams of water? By the way, this was question 7. So where's sodium nitrate? NaNO3. We want 80 grams per 100 grams. Well, that's right here. This is our intersection between sodium nitrate and 80 grams per gram. So that is at this temperature down here, 10 degrees Celsius. And so that's going to be our number 8. That's that. All of these graphing problems are just that. I don't see any questions, but are there any? I know I've held you for longer than I normally do, but that's just because I saw some issues in the chats. Okay. Your flipped assignment then or sorry, your independent practice is not on Quest. It is a quiz on the hub on solutions and solubility curves. And your flipped assignment due on Monday is the molarity Edpuzzle. Those are your 2 assignments for today.